Alright, and we're live. Alright, so it's been a few days, I think about a week since I last streamed, and I've made quite a bit of progress on the language. I don't want to go too long without streaming on it or doing some kind of recording because it's kind of a lapse in continuity that way. So I'm going to just be sharing what I've done in the past week or so, some of the features I've implemented, and I probably won't be doing too much extra development during the stream. Alright, so the first thing I did was I began implementing LLVM backend compilation for the language. So essentially, if I run this with in verbose mode, oh, I did not expect to reach an error. Well, that's something I need to work on then. I think that's for an operator. Oh, no, never mind. I was beginning to implement another feature, references, but I haven't actually finished, so of course that's giving an error. So now let's recompile. And then we get an output. Now, by default, it goes through all of the tokens. This is stuff we've already gone over, but let me just scroll up to where it does that. So basically it just steps through every single character and it collects it into individual tokens. So that can be words or symbols or strings or numbers, things like that. And then after all those are created, it generates an abstract syntax tree. And this is what that looks like. So basically it creates a global scope. This right here is an import node, which basically just imports a module. And then there's the function definition for this operator overload. That's a new feature. And yeah, basically it creates the entire abstract syntax tree. And then after the abstract syntax tree is created, it runs this function right here called generate output code, which looks at the abstract syntax tree and goes to each node of it, and it calls a function that generates that node, like generates the code for it. And so, for example, for this main function, or no, let's actually look at, let's see. This operator overload, which is just a function, by the way. So it basically looks at this first node, and then it looks at all the nodes that are children of it, and it generates all of the required LLVM code, which is sort of like, it's called an intermediate representation. It's like halfway between a language and like assembly, and you can just compile that directly to machine code. So if I go down, it's also printing out what the intermediate representation looks like. So these are just the passes. It's a 2-pass compiler right now. I'm not sure if I'll need more than that. Basically, the first pass is just creating function prototypes, so it knows, like, is this function defined? And then the second pass is the contents and everything like that. So this is what the IR code looks like. And for the function, it's kind of similar to like a normal function definition, but there's a lot more details here. So it generates all of this, and like there's an if statement, there's variable memory allocations, things like that. And then these are the return values. And the way that all of this is done is in a pretty high level way. It uses the LLVM intermediate representation API. So basically you like, let's see. So like this is for a for loop. You generate like the start value, for example. So you have for int I equals 0. That would be this start value. This would represent 0. And then, you know, there's blocks here where you can like put individual pieces of code. This is an allocate, so it allocates the necessary memory space for like a variable or something. This is an allocate for the iterator, and then it stores it, branching to the condition, and then it like does checks and loops and everything like that. And it's basically just like a high level way to generate the lower level code, and it does a lot of things automatically, which is super nice. So I won't really get into them. There's a lot of documentation, and I'll just probably start talking about the features now. So I finally decided I'm gonna have types defined like this. So you have an identifier, colon, then the type name. And you have operator overloading with saying like binary, and then the operator itself. And then also unary exists as well. Let's see. Oh, and extern, that's basically just including functions from the C standard library. So right now I'm just including printf, putchar, and malloc. So, I mean, you could just straight up use those. I created pointers as well. Basically, they're defined as, you know, an asterisk and then the type. So that represents a pointer type. And I kind of like this syntax better than, you know, the C syntax, which is type and then asterisk. I don't really know why they have it on the right side of the type name, when all the pointer operations are on the left side. Like this is the address of operator. It's ampersand and then a variable, which takes the address of it. And that's on the left side, not on the right side. So the pointer, that goes on the left side. And same with for the dereference operator, that also still just stays on the left side. And for type names, I wanted those to be kind of like the C++ type names, but a little simpler than that. Basically, I made them these. So this is like a signed int 128, signed int 64, signed int 32, and int is just the same as a signed int 32, just as it is in, I think, most other languages. And then I also have uints, so these are just unsigned integers. And then character, uCharacter. I'm not sure if I'm going to have... Currently, uCharacter is just unsigned character, but character is also unsigned, so both of these just mean the exact same thing, but I'm not sure if I want to keep it that way. And I also am not entirely sure how I'm going to handle Unicode characters. I might make a separate character type for that. Haven't decided. And then floats and doubles. And I'll probably make it so that I don't have an irrational number type. No. I'll probably make it so that you can do like float 32 and float 64 as just sort of shorthand for double and half. Oh, let me actually show you a program running. I forgot to do that. So this compiles. So if I just go over here, and then if I bring in this window, that's the program running. I don't have strings yet, or arrays. I'm pretty close, I just implemented pointers, but, you know. So basically, the first thing that we do is we put a character X. X is just 70 plus 2, and that's just the character H. So that's that one. And then it adds one to that, and then it puts that character dereferenced from the pointer that was pointing to it. And then that's I. And I don't do anything with that yet. Currently, this is a overloaded operator, so 1 bar 0. That's not actually defined in the compiler itself. I'm going to have it defined in the compiler just because operator precedence is kind of important for Boolean operations. But right now that's just defined up here. I compile to LLVM IR, and then I use Clang to link it. And then I think I already mentioned that this is how for loops are defined. And yeah. I also have tests that run. I get rid of verbosity. All of these run to make sure that the generated code actually works. I don't have any like output checks, but currently it just checks the AST to make sure it's well formed. So it's not super useful unless you're working on the AST. Yeah, it was surprisingly easy to actually implement the LLVM backend. I mean, I took like a week off of streaming to do it just because I'm sometimes more productive, you know, learning just on my own without some kind of audience. And the tutorial they have on the official llvm.org website is for Kaleidoscope, which is like a sort of more basic language. And that's... I've used it a little bit for implementing some features, but it's not super good in my opinion. But I think it's relatively easy to get going. Also, I have a lot of commented code out that, like for things that don't work. Alright, so now I'm going to work on the bracket operator, which is like a sort of special type because it's not like a single symbol. So that's... Oh, and the reference operator. Basically, the way that I think I'm going to do references is the same way that you do pointers. Oh, that's down here. So currently, if I do int pointer, it basically is just like a unary operator on int, and then it just handles that on its own. It knows how to handle that because int is a type. But I also want to be able to do ref int, and it should be able to go on either side because it is unary. But then ref will just be an operator. So let's actually do that first. I think it's here. Oh, and I forgot to mention, LLVM does not support like operator overloads or function overloads. So you actually have to do name mangling, which is basically like adding characters and types or whatever to the name of the function itself. So I don't have to do that for these extern functions. And I don't think I actually have that for... Yeah, I don't have that for normal functions yet. But what I do use it for is for operator overloading. So if I go up here, the name is just binary.var_bar, which is this right here. Because this isn't a normal function, it kind of needs to have its own unique name. But this will apply to like all functions so that you can overload them. Alright, so I want to have a special sort of case. So currently, the left bracket and the right bracket, those are individual tokens, but I want it to be so that if you have something like this, where they're right next to each other, then that'll be a single token, because that way I can use it for defining arrays or whatever, things like that. What should I call this? Both brackets, I guess. Under right. Alright, and now I'm going to do this. Basically, this is the map that is used to check if it should keep adding to the token. So if it's on a left bracket, and the next token's a right bracket, then instead of making these individual tokens, it'll combine them into one. And then this is the one that's used to just change the type. So like if you're on a left parenthesis, by default it makes that punctuation. But afterwards it'll process it and it'll change it into this type, and so on for all these types. So technically ref is going to be an operator, but I think it makes sense to put it in the keyword category. And the other one was both brackets. Also, I have all of these symbols that don't do anything, but they can be overloaded. Although I think I am missing some. Like I probably want to have like arrows. All right, so now for ref, I want to, let's see. I'll go to where my operators are. And set its default node type as reference operation, which I also need to add now. Let's see, where should that go? And I think that's it. That should be the operator implemented. So I'm gonna make a file. Unfortunately, since I've added LLVM, compilation takes a bit longer. I changed to Ninja, but that hasn't really improved speeds at all. LLVM is just really slow to link. I mean, for reference, it's already taking like 30-40 seconds, and I think in the last stream that I showed, it was basically instant. You know, I could make my own intermediate representation, but that's too much work. Alright, so now if I run this, yeah, okay, it worked because it didn't segfault. So now if I go to where that is defined, did I uncomment that? Alright, so modify reference should be under print int. Okay, did it just fail to create it? I might have forgotten to place an error somewhere for the argument creation. Yeah, because now it's there. So let's see what the oh, maybe I just forgot to save it. Yeah, because this time it threw an error. Invalid argument type given. And that's expected because it should have an invalid argument because it doesn't know how to deal with that. Is it not? Okay. I may have forgotten to add pointer functionality as well here. Guess this is a new feature, so it's kind of okay. Yeah. Forgot to do that. Oops. So let's just see what the AST looks like. So the identifier has the type as the child. That's how it works. Pointer, and then identifier. Alright, so I want to add a boolean to see if it's a reference or a pointer. Okay. If type name is ref, then isref is just true. And then I also want to continually get if it's a pointer. Okay. Inside of here, I actually want to instead of making this type name, it should be a node actually, so I can kind of recursively make it its child. Type node. The arguments first child's first child. So that would be that. Then I'll set type node equal to type node child node 0. And I'll also have a pointer level set as 0. That way you can have pointers to pointers to pointers as much as you want. So that's pretty handy. Alright, and then I'll see if the new type node token up first is a pointer symbol. And if it is, then pointer level plus plus, and also go to check pointer. And basically that'll just pop off all of these pointer symbols. And now for the mangle name, I actually want that to, let's see. Type node token dot first. So this one is for getting the actual type name. This one, I want to add a string for pointer. So I'm not adding asterisks. I'm not sure if LLVM supports asterisks in the intermediate representation, but I don't need them, so I'll just switch it to a string. And then for this one, I'll add ref. Basically, this is just mangling the name. Doesn't actually have an effect on anything. So this right here is basically just a function I created that takes a string that looks like one of these types and then returns an LOVM type object, which is like more robust sort of thing. And basically I want to modify this for pointers right now, and the way I can do that is, yes, goto, very good. I actually have started using those way more since dealing with lower level languages like my own for the AstroSam. Alright, so basically down here, I want to create a for loop and continually get the type as a pointer type until the pointer level is 0. Or until int I is less than pointer level. And the way that I'm doing this is deprecated, so it's not the right way to do it, but I don't feel like looking up the right way to do it, so a type is equal to a type get as pointer, I think. Hold on, I forget the exact way to do it. Get pointer 2, that's right. And I think that's it. Although I'm not sure if in my function code generation it has support for pointer arguments. Actually, I think it does, but it passes it as a... Yeah, so it does. And it works the same as it would in, like, C. Basically, it creates a copy of the pointer in memory. And then that's what reference is for. Type was not declared. Oh. I'm not sure how LLVM supports references, or if it does. Type name was not declared. 1022. Okay. I don't think that's right. Type node. Where do I use arglist? Do I even use that? Oh, it's for function IDs. Okay. currently I don't use the actual type names in function IDs, which is basically just a list of like function prototypes that I can use to look up function calls so that I can find like the best matching function. I'll show you what it looks like in a second. I don't think it's very well made, but it was sort of just the best way I thought to do it. All right, and then type string. Let's see if this compiles. That's right. Okay, hopefully that's all. These warnings are annoying, but they're not that important. They're for this getPointer2 function that I'm calling, because I'm lazy and I don't want to look up the actual way to do this. I'm pretty sure that LLVM has like switched over to a much more type strict way of IR generation recently, which I don't really like. I mean, I didn't use the old version, so maybe there were a lot of fallbacks to not being strict, but there's a lot of having to deal with stuff, basically. Right, there we go. So now we can have pointers as arguments. So I'll just show you what I was talking about. Go up here. Basically, I have a struct called function ID, which contains the name, like the original name, the mangled name, and the return type, and also a list of arguments. And basically, when there's a function call, you have the arguments, that you pass to the function, and the type of those arguments, and also you have, the function name, of course. And so, when actually trying to find what function the person is wanting to call, I run compare match on each of the functions, and I try to find the one with the least number of individual differences. So basically, first it checks, are the names the same? If they're not the same, then obviously it's not the same function that you're trying to call, so it returns the highest value, which is just 1,000, I guess. I don't really, I mean, obviously it should be the max int, but I just was typing this really quickly. And then if the arguments don't have the same sizes, then return 1,000 minus 1, because, the name's right. I'm going to change this in the future, because obviously you should be able to have default values, so the size is not a really big factor. And then I go through each of the arguments, and I look at the types of the argument. And if they're both integers, which is basically what this code does, it just looks in the, it looks at the enums, basically, for the types. So everything between integer and Boolean, all of this stuff, all of this those are just integers. So if both of them are integers, which is, yeah, that code there, then it checks to see how far apart they are. Like if you have a signed int 128 and a character, those are sort of seen as less close together than a signed int 32 and a 128. I don't know if that's the best way to do it, because, you know, there are times when, you know, you want to convert completely different types, but... And if they're a different type, then it gives the max difference value for that. And also does the exact same for float types. And yeah. And then if they're exactly equal, then the difference is 0, of course. And then this way, you can still call a function. So if I'll go to here, if you want to call printInt, but you don't have an int type, you have like an unsigned int 8 or something like that, you can still call printInt on it, because printInt will be the most matching function. But if you have a printInt and it's like int 16, then this one is actually going to be called for the int 8, because the type matches better. And then obviously if you have an int 8, then if you pass an int 8, it's obviously going to pass this one as well because it matches exactly. So basically, it doesn't need the function to exactly match, but if the types are similar enough, it'll automatically do the cast. Which is like standard in languages. I'm not sure if that's the way that most languages do it, though. Okay, so I think ref is basically... Is that basically just handled as a... I think that's just handled as a pointer, right? So right now, let's see, what does the codegen do? So yeah, there's ref there. Hi, welcome to the stream. This probably won't be a super long one. I'm basically just showing what I've done so far. And I'm working on finalizing reference implementation now. So function. Let's see, how do I define that? String and AST node type. All right, that's a little bit of a problem because currently it gets rid of the fact that it's a pointer. Maybe I'll just, I don't know, create a struct for an argument type. And then that way I can have the AST node type as the base AST type. And then I can also have the pointer level and is reference, that needs to be a Boolean. Because I think the only difference between references and pointers is that pointers, well, references, it forces any arguments passed to the function to use the address of operator before. I'm pretty sure, yeah. Alright, so now when I go through an argument list, I need to actually look at the values. So this one is talking about the base AST type. I think that's all I have to care about there. Alright, and then for arg list, I actually need to do this a little bit better. Arg type. So it's the type string, and then the type node. I think it's just, yeah, type node itself. And I need to pass the pointer level and isref. Yeah. Is that the only place it's used? Seems so. Let's just see if that compiles. And then obviously for any function calls, it's going to have to force using the dereference operator before the values are actually passed. Hey, it worked. Nice. Let's just make sure compiled code still works, though. Let's see, where did I put that? Right here. And it still works. Nice. Another thing that I need to do is implement better testing, because currently it just checks the AST, but I also want to actually fully compile programs and then check the output. And I want that to all be definable inside of the program itself. Like, you should be able to do some kind of compiler directive like est or something. And then it's like some kind of call or something like maybe print, because I should be able to check the output of anything that's run. Or I could do some kind of Boolean operator, perhaps. Yes, metaprogramming. Like 1 equals 1. Because then, if this is reached, it'll sort of like evaluate this. Then if the value is like false, it can throw. But I kind of want it to be more complicated than that, probably. Alright, so now that I have references working, well, in function definitions, I need to put it in function calls. Generate call expression. So basically down here, why is this? I don't think this is my code. This is terrible looking. Basically right here, this is where I want to take the reference, or take the address of. Oh, I can do that, I think. Wait, no, I can't. Because there's the pointer type. Yeah, this is a value type, not a pointer, or not a type. So I think I have to modify the AST node itself, perhaps? I don't want to modify the AST at all outside of the AST generator, so I think I have to... Yeah, I think I have to find a different way to do that. Maybe I can call a function on it, like address of passing a value pointer, and then that'll return a value pointer. Well, actually, it'll return a void pointer, and then I'll pass it to a value pointer. Because that way I can use this function for, like, functions. And then address of operator. Music. Let's go. Hold on. Wait, do I not have address of operation? I will not take your word on that. Oh, I see. So address of operation. Okay, so the way the LLVM code gen works is kind of weird, I think. Basically, when you define a variable, what's returned is a pointer to the variable. So you have to, like, if you return the variable itself, then you're actually returning a pointer to it. But if you want the actual value in the variable, then you have to create a load. I guess it does make sense. It's just like kind of weird. So for AstroSam operation, all I have to do is return the variable. Wait, so how is that different from what I was doing? Oh, so inside of this code gen itself, it was already getting the value. So I can't have an address of here because that's already too late. Interesting. So basically the problem that I'm encountering is the fact that if you were to pass like a variable to a function, but the function says ref, the variable is already loaded. So that's generate variable expression. So basically it looks it up and then it loads in the value. Maybe I could have some kind of like value is ref or something. If it is a ref, then I can just return A. And then obviously I need to add that to the AST node, which I can do actually down here. So technically it's modifying it at runtime, or at compile time. This might come back to bite me. But for now it should work, I hope. So basically now I can set isRef equal to true if it's expecting a reference in the call expression. So if args I wait, args is an AST node pointer. Get function from ID. Ah, I see. I want to actually return a function ID. There we go. Pointer. Yeah, function ID pointer. Or just itself. I don't care if I'm copying, it doesn't matter. And then I can get fn value on my own. Okay. Oh, and I have to do that for the rest of these as well. And then fn value. Oh, maybe it should be a pointer. That would just make it easier, probably. Function pointer poly f is equal to dot fn value. And everything down here should be the exact same. Let's make those pointers. Alright, and then now for these, I can go, instead of iterating through args of a AST node type, it'll be poly FID, arglis, I forget. No, arguments is reference. Arguments I dot and if it is a reference, then I'll just modify the AST node to mark it as such. So the args I believe isref is isref shared? No, it is reference. I need to have more common naming. Okay, so then if it is a reference, then that's going to be marked. And then instead of returning a value, it should be returning a loca. Okay. Yeah, I didn't expect that to work. Oh, get exact function from ID. That was the other function that I forgot. Oh, that was the only place I used it, I guess. FN value, not FN val. And 4429. So these are just warnings. Okay, and then error cannot convert function ID to function ID pointer. Oh, I forgot. Yeah, that needs to be a pointer. I only did it for that one. I think it's compiling. It's good. You know, I am enjoying the process of implementing the LLVM backend. It's been pretty easy so far. Some things I'm probably not doing correctly, but you know, the code runs and it compiles my language, so I'm happy with that. But the downside is I said I was going to make ASA compatible with the Astro 8. So I'm either going to have to create my own backend, like entirely from scratch, which might not really be worth it, or I will maybe try modifying LLVM to add an Astro 8 output. Not entirely sure. Or no, sorry, it wouldn't be LLVM. I'd have to modify Playing, which is actually the program that's used to compile the IR into machine code. Alright, segvault 1116. Oh, that's right. The function ID Alright, I think that's right. There's probably another instance where I'm trying to access part of a null pointer, so may crash again. And there was 1089. Let's see. If the function ID, then return function ID. All right. This is going to be another one of those cases I need to fix. So I'll do poly f is equal to call the ID fn value. All right. Let's see. What is this from? Generate function? 1128. Interesting. Function empty. I'll be honest, I'm not entirely sure what that error is from. It's being caused by checking if it's not empty. Oh, wait. Now I see. Yeah. So if the function ID is not defined, then we generate the prototype. But if it is, then we want the function to equal the function ID function value. And then if it's still not, then, return null pointer. Or if it's not empty. Okay. I really just wish recompilation, between, every change that I make did not take so long. There's probably something I can do to speed it up a bit, but all right, and that worked. Now let's see if we have references. Oh, actually, the only change here would be, okay, it is a pointer. That's good. But now what I want to do is actually call this function, because I haven't done that yet. So if I call modify reference on, let's see. Let's try running it on X, which is 72 here, and then it gets changed to 73. And let's just run print int on X then. So it should print out 4. Let's see where I put this. Here we go. Y. Okay, it's printing Y currently. For printing int, meaning that it's outside of the range of integers. Which means that it's not changing. Alright, let's look at the IR. Should be looking up here. Modified reference, I32, X underscore load 8. Oh, odd. Basically, it's loading in the value of X, but I don't want that, and it shouldn't be doing that either. Interesting. So it's running this code, which is clear. But it shouldn't be. Because that's X underscore load. Okay, I need to fix this. It's just terrible. Yeah, I think the problem that I'm having is the fact that I'm marking the argument as a reference, but I think it's actually an expression. So if I go to a function call, yeah, the arguments are expression terms, so it actually needs to be the child of the expression term. And then actually, I obviously need to do a check to make sure that it's actually possible. So if the argument I child nodes dot size is greater than 1, or child nodes 0 node type is not equal to identifier. And at the beginning, I actually want to do if it's not equal to 1, so it needs to be exactly 1. If it's 0, or if it's 2, yeah, okay. I'll throw an error. I will implement better error handling, but not right now. Okay, and then that should be it. Basically, what I'm talking about is the fact that the argument is actually a list of expression terms. Oh, was there an error? Identifier node. Oh, that was not an enum. So the argument is actually a list of expression terms, and then it evaluates the expression inside. So I need to set this specifically as a reference and not this, because obviously you can't get a reference of an expression. Identifier node. And also if there's more than one node within the expression, it's not just a single variable. I should obviously make that a bit better, but it does check to see if it is an identifier as well, so it's probably good enough for now. Oh, there's a comma there. Another nitpick I have of the LLVM like example project basically like tutorial of how to implement LLVM for a language is the fact that whoever wrote that, their C++ style is some of the worst I've seen. Alright, this compiles. That's awesome. Now let's just see if ref actually works. It does not. So let's go to where that is. Modify reference. It is a pointer this time. Last time it was an I32. And it... Wait, it's using X. Okay, that's kind of odd. So that means it must be happening... The problem must be in modify reference. Alright, pointer N. N1. Wait, it copies. Into N1. Okay, I won't lie, my LLVM IR reading abilities are not super great. So I'm not exactly sure what the problem is here, but is this copying the pointer N to a new to N1? Or is it copying the value within it? No, it shouldn't be copying the value within it because that needs an explicit load. Like this. Huh. Let's see, modify reference X. Let's just see if it changes at all. We put char. Okay, so it doesn't change it at all. I wonder if it changes it if instead of passing by a reference, I pass it as a pointer and do the same over here. Okay, so that doesn't do anything then. That means that inside of the function generation, it is doing it wrong. Yeah, just generating the arguments wrong. So that's happening right here. I think if I get the function ID again, have it even after creation. I don't know if it returns like an array type or something, but I need to add an iterator to this. Actually, I think there is a way to do that. Whatever. Instead of that, we'll do I is less than yeah, I guess no, function ID. Alright, let's Alright, so if that compiles. It's not. No match for operator. Because it like returns an iterator. Okay, there's a better way to do this then. Like this. That was actually way faster. I could have done that in the first place. The function ID argument dot oh wait no at I dot let's see if it is a reference or pointer, then I don't want to copy. Actually, I don't need to do a check for both of those. I can just check if pointer level is greater than 0. Then actually, if it's equal to 0, then I'll copy. Wait, and that's a loca. Oh. 0 else. So if it's equal to 0, then create a copy. That should go down there then. Otherwise, set it equal to arg. believe. Address that. Wow, I'm looking at the stream stats. I think this is a record number of viewers. There's 14 people here. I didn't even... Oh, 15. That's quite high. Normally it's only a few. Let's see. Error. Generate function. 1151. Oh, wait, here? That's interesting. Arguments I. So I believe that means it's out of range, but I'm not sure why the arguments would be out of range. I'm not sure how to get the number of arguments. Let's see. I think one of the big downsides with LLVM is that the documentation is kind of iffy in some places. I mean, they say it's because it's the changes happen, you know, often, which is true, I think, but kind of get lost. Hello, welcome to the stream. So I don't think I can do a check to see if the arguments have the same length, because I'm not sure how to get like a definitive integer value for the length from arguments. but I can just do a check in here. If the function ID argument dot size no, actually, I do want that to be a pointer. Let's see, then that token. Oh, something I completely forgot to mention. I also added colored output to the compiler. I have like a header file or whatever that basically handles all color printing for every platform, and also it like disables color printing if the terminal that you have is doesn't support color. Like for example, this terminal right here, which is just it's just like the NeoVim command line. So you can see the colon right there, and then just like runs that. That's the command that I'm running. It turns off colors. See, this is the output of the compiler, because it does run it every time I compile, just because that way the tests run and everything. Normally these OKs, you know, those are green, and you know, there's color. And if I run this, you can see. Now that I'm inside an actual terminal window inside of NeoVim, there's actually color here. It's pretty basic, I think it's kind of important because it helps, you know, differentiate different parts of your output. I didn't expect there to be another error because I added error handling. Generate function 1150 now. Arguments dot size. Wait, is arguments null? Huh. I think arguments is null. And the only reason why arguments would be null is if the function ID is null, I believe. But generate prototype should create a function ID. Yeah, it does so right here. So let's see. Maybe I have to add a check. If not the function ID. Really, this shouldn't ever execute, so I'm kind of concerned why that's happening. Unless it's the case that the function ID is being defined, but the arguments list is not. Although it should be, because I do initialize it with a blank vector. Yeah, there was a failure to create a function, so it's not being created then. I don't know why the output looks like this. It's kind of weird. It should be lining up over here, I believe. Get function from ID, token dot first. Generate function should be... Oh, hold on. I think I might know why that's happening. This is for operator overloading specifically, I believe. So let me just comment that out for now. Also where it's used. Okay, now it works. Okay, so I now know what was happening. Basically, operator overloading the token for the name is not what you actually have here. It changes, I believe. Dora, I'm surprised you have classes now. It's middle of summer. Unless you're taking summer classes. Let's see. Oh, actually, let's just see if this code works, because I believe that was the only thing holding it back. And it works. Okay, so we have pointers working as function arguments, and that should obviously mean that references are now working as well, which is what we set out to actually accomplish. And they are. It's a question mark, so I should probably make this print int. So basically, it starts at 72. We add 1 down here, so it's 73. And then we change it to 4 within this modify reference function, so it should be printing 4. And it works. So we have references and we have pointers as function arguments. Awesome. Okay. So the problem that we were just encountering, that was for operator overloading. And I believe the reason why that was happening was because the token of the overloaded function, which is basically just this thing, like for print int, this is the token. I believe it's wrong for... No, I have to actually recompile. The AST is very large for such a small program, but it's verbose, so it's pretty useful, actually. Okay, so that's why, because it's just binary, when it should be binary or binary bar bar. Interesting. So I think that's happening in parser.c++. Compiler define. You know, funnily enough, I actually removed the AST optimizer. I actually had one. It would like optimize, it would do basic optimizations like Basically, if you had something like 1 plus 5, it would just output 6, so it would remove the addition operation. But the thing is that LLVM actually does that automatically when you output the IR. So you genuinely don't have to do that. I mean, there probably is a use for it. But if I'm allowed to be lazy, I think I'll just be lazy. Oh wait, no, this will be compiler-defined function. That's right. And then, I don't remember if I have a special case down here for binary and unary. No, it seems not. So that would mean... Oh, that's right, this is counted as like some kind of operator, I believe. I genuinely forget how this is gathered. Oh, it pops it off the top of the stack, that's right. Meaning that it's created somewhere else, I believe? It is. So it's created down here. Operator overload node, which gets changed to operator type node, I believe. 4. So I think I have to change the token, I guess. And I convert that dot second. Oh, and I actually have to add a dot here. All right, let's see if that works. Oops. Got a plus. I've probably been putting off adding arrays and strings a little too long. I don't think I'll be able to fit those in on this stream, though. I think after I fix this issue, I'm actually going to end the stream. Whenever the compiler decides to finish. Ah, there we go. And for some reason, no warnings this time. Alright, so now that should have name mangled the binary OR. Inside of the AST, that's right. I need to do that in the AST itself. It was already doing it inside of the IR. Oh wait, but then in the IR... Yeah, so binary bar bar. That would mean that in the IR, you would be mangling it a second time. Never mind. Okay, that's interesting. Whatever. If it works, it works. There's a very good reason why this repository is still not public, because my code so far is going to be terrible. And that works. Nice. Okay, I said I was going to end the stream after that. See how long the stream's actually been going for, though. 2 hours, 15 minutes. That's probably good enough. I'll stream again sometime soon. I probably don't want to go as long without updates as I went when I was implementing the entire LLVM backend. But let's see. Oh, actually, let's not end right here. Let's try and add the arrays. Luckily with arrays, I don't think that'll be that difficult. I just need to... I mean, I have malloc. That's like... That'll work for dynamic arrays. I believe there's probably a way in LLVM to just create fixed size arrays. I'll have to look. So basically I created the operator for open and close bracket. So that would be unary that I'm just thinking about how I'm going to how operator overloading will work for this. Because I think it's technically possible to do like this. Oh, but unary... That wouldn't be unary, that would be like binary. Yeah, it would have to be binary. If I can spell it right. And then the first value is like an int pointer. Second value would be an index. Also of an int. And then you can return dereference or dereference I plus index. All right. I don't have brackets created yet, though, as an operator, so I need to do that manually. 4. Okay, I thought this would be faster. Wait, what? I think I'm missing it. Oh, no, it was plus, not add. Oops. Alright, and then that'll be, I think I called it both. Yeah, both brackets. Oh, wait, no, I don't want to use both brackets. I want to do left bracket. Both brackets is used for overloading. Oh, did the music end? Yes, it did. Let's change it. So if we reach a left bracket, it's kind of different from a normal operator because we go to the right bracket. Currently, my code for gathering is pretty terrible. It doesn't have a lot of cases programmed in, so some standard C code might not work. Or, like, you probably just have to be more careful. Like, I think I don't have support for expressions. Yeah, but it should be basically a drop-in replacement for, like, a really good function that I have not implemented yet. So I think I want to create a new node type as well, and call it access operator. Or access operation. And then set this as the default node type for left bracket. Yeah. And then I don't need to actually do, yeah, I don't need a bool for each bracket operator. Or I can have that maybe down here, and that's equal to node type is equal to access operation. And I'll actually just call this is access operation. And we also want to make sure that it's not unary. Alright, and then else, if operation with brackets, there's probably going to be more cases, like special cases, but for now I think this is okay. Then I'll just copy this. You know, I think my standards really are just better than C#. Just create a language that is better than C#. So far, I think I've done that. No, I've definitely done that. C# was basically a string processor or something. But this one, it outputs like a real compiled program. And the syntax is not horrendous. But I'm not super concerned about the compiler itself. If someone wants a better compiler, they can make one. I mean, like, the language is going to be hopefully well-defined. No, not C#. C# is probably... Well, I'm not a huge fan of C# either, but it's, the compiler is probably a bit better. Just a little bit. So then for this operator, we just want to check if the bracket level is equal to 0. I believe that's it. And I'll also throw an error for a missing closing bracket. Hi, welcome to the stream. This project is basically a programming language. It's inspired by Jonathan Blow and Jai. I think it's pretty clear, like, given the style. Basically, I'm just working on the compiler right now. And it does compile. This is what it looks like over here. And you can pause it if you want to see any of that in more detail. At the moment, I'm working on the access operator, like for arrays and stuff. Right. Does not compile. Generate variable expression 37. Let's see. What is that from? I think that's from this. Yeah. Let's use the access operator down here somewhere. The name's in the title of the stream. Let's see. ARR. Let's just do like ARR. 2 is equal to 74. 4. Yep, there's an error. Oh, but the error is not in the AST generator. I'm only working on the AST generator right now. That's all I have to be concerned about. Access operation, left and right. Okay, that works. Now I just have to implement the access operation inside of the code generator. It doesn't stand for anything. I just made it up. So that is in generate expression, I think. Oh no, it's like binary expression. Yeah, generate binary expression. That's good. Programming is good. You should be doing it. I only took a 4-month break before deciding to embark on this project. Huh. Not entirely sure why it's throwing an error instead of, or why it's seg faulting instead of properly throwing an error, because I think I have error handling for this. Oh, that's because expression statement expects an identifier, not another expression. At least I believe so. So that should be super easy to fix, I think. Famous last words. Statement, expression statement, that's what it's called. Alright, so identifier node, child node 0. Okay, so let's just comment this out temporarily, and I think I can do... Right now, it's looking up the variable, but it might make more sense to... do code gen for it. Like expression node code gen. My operating system is Windows, and I'm... Well, here. Oh wait, hold on. There we go. I'm using Windows subsystem for Linux. So technically I'm using Debian inside of Windows 10. That's my operating system. So I think I want to do identifier node code gen. And the way that I generate the code, I call code gen on every AST node, but code gen is actually a function pointer to one of these very many functions for generating all sorts of things. And so the way that I call it is very stupidly. This is probably some of the worst C++ syntax I've used in a while. It's terrible. Basically, like, yeah, I don't even want to go into that. So that's variable, and that's identifier node. If I'm lucky, that should be compatible. Oh, no, the reason why that won't actually work, it'll probably compile, but it won't work, it's because I need to look up if it is a identifier all on its own. So if identifier node type is equal to identifier node, yeah, I'm programming a programming language compiler for a custom programming language. You can go to the beginning of the stream if you want to see what it looks like. I'm busy now. So if it's just an identifier, then we can just load that. And if it's not an identifier, then it's just an expression. We actually want to compute the expression. Okay. Yeah, I've been using NeoVim for not actually that long. I used to mainly use Visual Studio, but Visual Studio is kind of bloated, and also my laptop is Linux, so I kind of had to choose an alternative, and I hate VS Code. It's the worst. So I switched to NeoVim like 3 years ago, maybe. Oh, you have poor quality text? Let's see. I might have a different font installed. I don't know, I've been using the same Windows install for, let's see, 8 years. It's been the same install for, I think, 8 years now. Left and right argument to operator must be the same type. Okay, so I have to remove that check for this case where they're not expected to be the same type. Yeah, okay. Left and right. Oops. Left and right. Left and right arguments for operator must be the same. Let's see, so I think that the way I could do this is... Yeah. So right now I have it as generate binary expression, but really it should probably be its own function for generate an access operator. Generate access operation. And then I can copy some of this, but I don't need all of it. Actually, I'll copy all of it and then remove what I don't need. Alright, and then child nodes 0 should be some kind of pointer type. I think I only store if it's a reference, not the pointer depth. Yeah, okay, I say I hated VS Code, but now I don't think about VS Code anymore, so I don't really hate it. It might have gotten better. I think what I have used... I've used VS Codium, which is like a fork without like the tracking stuff that Microsoft puts in. And the only reason why I used that was for my custom languages for AstroSam, because it's really easy to create a syntax highlighter for VS Code, which I guess is a nice thing. But that allowed me to have syntax highlighting for working on projects in like a custom programming language. I think I can Here, 613. I think I can get if it is a pointer. Yeah, use pointer type. No, I have to use get type is pointer type. 613. So if L get type is pointer type, it's equal to false. Or R get type is integer type, it's equal to false. There we go. Alright, thanks for joining. Actually, I'll separate these out. Yeah, separate those. Left argument of access operator must be a pointer type. And this will only be for built-in. You will be able to overload this operator. So obviously you'll be able to use the access operator on something like a string or something like that to get a character. But string in this language, I'm pretty sure is just going to be like a struct. So it will have to be overloaded. An integer. There we go. Check to see if the operator has an overload. I'm going to want to change this actually in the future for this and binary and unary operators for function overloads to make it so operator overloads are for exact matches only, I believe. I'm not entirely sure how that's going to work. Yeah. And then the difference between this and a binary operator is the fact that the left argument is not loaded, it has to be a pointer. So if it's a built-in operator, then I want to add, let's see. I mean, L should be a pointer, so then I can just add 1 to that. Wait, no, not 1, I want to add. Can I just do L and R added together? New address, and then create a load from that. Or no, actually, I want to return. Yeah, this is an access operation. Do I just want to return the new address then? Let's try that, see if it works. Well, it didn't even compile. Oh, I need to actually add that to the global definition. Let's see, where is that? Oh, it's under unary. I didn't need to do that. Let's put it above unary. Or below binary. Yeah, below binary. Let's see. Operator overloaded. Yeah, that's right. I got rid of that. 632, 36. Generate binary expression? That is defined, so that's concerning. I'm not entirely sure why that's like that. Generate access operation. Why is the error on 632? 636. Operator overloaded, so that should be... Oh, actually I can just create that here. Okay. Left right arguments of operator must be the same type. Oh, that's right. I need to actually change the code generation function. This one's generate access operation. That needs to be changed in here. So if is access operation. I kind of have that backwards, but whatever. Node code gen is equal to AST node. Generate access operation. Actually need to get the address of that. Okay. I swear my computer is fast. Right. Where does that happen? Generate expression statement 449. Get LVM type from string. The type is array. I'm not sure why it assumes that's a type. So 449. Go there. So var is find named value only if it's an identifier. If it's not an identifier, oh wait, hold on. That's not for the same thing, is it? Let's comment that out and see if it works. Oh, it does. So it was. .449. That's down here. Type node. So I want some kind of bool value to indicate that the left side is not an identifier, but is an expression. Not is left expression. Like that. Is the music over? No, it's just super quiet. Alright, let's see if that works now. The problem was that it was thinking that the access operator was a type just because of the number of children it has. I don't play a playlist really. It's actually on YouTube. My second channel is what I'm signed into because that's what I'm streaming on. And basically, sometimes I just search up streaming playlist, and now my recommendations is just like stream music basically, or just various types of music. Last stream I played copyrighted music, so now my video is actually restricted in a few territories, but none of my streams so far have gotten a copyright strike, so I think it's okay. Oh, this compiled. That's surprising. I probably should find some music that's like all copyright free and also fits the streams well, but right now I basically just click on something. So now I'm going to try printing the value of the array, because right now I have no idea if it is set to 74 or not. I mean, it seems to compile. That's interesting. Ah. The first ASA seg fault. That's a shame. I'd gone so long, but you know, once you start dealing with arrays, I guess that's what happens. Malloc. I'm pretty sure that's... Is that in bytes? Hold on. I might want to have to... Yeah, Okay. It's my fault for not using C ever. Size of... I need to import size of. Oh wait, no, I can't do that, because I don't have a type, I believe. Wait, hold on. What does size of take as an argument? Size of operator. Oh, I guess an expression? I'm not sure if size of is actually a function or if it's more of a compiler-defined thing. I mean, let's see if it compiles. Okay, it does compile. So let's malloc 8 times size of an integer. So I can't type int because I can't pass a type. I don't have that functionality, but I don't know, 1. Yeah. So, oh no. Okay, so it doesn't work. Size of doesn't. Okay, but let's just do 8 times 4, because I know that 4 is the number of bytes of an integer. And let's see if that works. Segfault. Nope. It should have 8 times 4. Here, let me comment out a lot of the stuff that doesn't matter right now. That should make it a little bit clearer. So basically, ARR is defined as an int pointer here. Well, no, it's defined here. And that's equal to malloc 32. So it's 32 bytes. Okay. Zero int to pointer. So I think that's just conversion, I think. Array load. Oh wait, so it's loading. I want to load the pointer itself. And I add 2 to that. Then I store 74 to the pointer. Pointer add temp. Wait. Store that to pointer add temp. What? I have to save that somewhere though. Okay. I want to know if the problem is happening there or for access. Okay, so it's happening for set. And then access. Well, I mean, it could be happening for access as well, but I don't think that throws an error. It's only when you write to out of range memory. Yeah, seg false. So that's in generate expression statement. And for node channel size. So I can't have type inference then. so if the left side is an expression, then I can do type is equal to var get type. Okay. Because that would be set up here. And then where the value is saved, down here, if not left, wait, hold on, left expression, is that what I call it? Is left expression. And if the variable doesn't exist, then allocate memory. If it does exist, then store. Actually, I don't think I need a check for that, but var should contain, let's see, should be the pointer. Oh, meaning that the issue is actually in what the access operator function returns. I've probably been doing this for too long, so if my current code does not work, we will be taking a break of about a day. Then we'll come back to it and see if I can actually fix the issue. Wow, that is a very long error. Generate expression statement. Hash table. Uh-oh. I don't even know what I use an unordered map for in this case. Generate expression statement 472. Type signs. Find out first. Oh, because it's a pointer. So I can't get the value of this. It needs to be... Well, I guess in that case it could be automatic. You said I definitely should use C. I'm probably going to be using a lot of C, creating the standard library for ASA, just given the fact that it's the easiest to use external functions for. So yeah, I'll probably be getting quite familiar with it. Although ASA is technically, I said, supposed to replace it. So after the compiler is done and the standard library, hopefully never again. I guess other than on microcontrollers and such. Actually, no, I could use ASA on microcontrollers. Well, that would probably be too difficult, because most work is already done in C. Well, because that's not working, I probably need to read up a little bit on the best way to do this in LLVM, with the LLVM backend. But yeah, I'm not going to do this today. So thanks everyone who stuck around to the end. This wasn't a super long stream, but I think I got a decent amount of work done. I filled you guys in on all the progress I've made in the past week or so. So thanks for watching, and I'll see you next time. Which is probably not tomorrow, but maybe tomorrow.